Basic quality and inspection, Deck 6, gas tungsten arc welding stainless. So what are we checking for? What are we talking about here? Well, we're talking about the surface condition, the weld profile, and discontinuities. And if you're getting into welding, and this is the basics here, but if you're getting into welding, we have terms like discontinuity, flaw, and defect. Everything that's a discontinuity is not necessarily a defect. So we can have discontinuities and defects. A discontinuity is just something that is not perfect. It's not how the rest of it is, but it doesn't mean it's bad enough that we have to reject the weld and or the base material. It's a discontinuity, just something a little different. If it's bad enough, we might have to reject it, and that would be a defect. One of the things we look at is acceptable weld profile. We don't want to have it humped up. We don't want to have excessive face reinforcement. We want smooth and even, consistent width. We want a proper tie-in where the toe of the weld and the weld just ties into the base material, and we've got, nice, smooth, even, happy weld. We don't want to have underfill, which in this bottom center, diagram shows us we didn't put enough weld metal in there. That one's a relatively easy fix. Granted, we got to come back in there and re-weld it. Not re-weld it, we just got to put more filler metal in there. So we can have excessive face reinforcement, or we can have lack of reinforcement, which is underfill. An easy fix. Excessive face reinforcement, somebody's probably going to have to make a grinding run across that. Get out a grinder and chew some of that metal out and, bring the top of that reinforcement down. Lose a little material there. Blend it in. So some of the defects that we can run across would be cracks. Cracks are bad. Never acceptable. Porosity, depending on which welding code you're working to, certain amounts of porosity are allowed. Some is not much. Some you can have way more. Undercut. Undercut is at that toe of the weld, and it's a little notch, and it can end up leading to, stress concentration, cracking, bad things where, there might be some stress in that material, and that's a crack initiation point. So we really watch out for undercut. Heat tint evaluation. So with stainless steel, and I didn't do too much of a deep dive into this because we're just at the basic level here, but heat tint. When we weld stainless steel, we really want to look at the tint evaluation of the steel. Evaluate the color when we're done, the stainless. So if it's a light color, we're acceptable. Darker colors, grays, this can indicate that we got it way too hot or we got shielding issues. But this is a whole thing. We could do a little deep dive into this and talk about this for a while. There's people that have put this together that are metallurgists and engineers, and it gives you a pretty good indication on whether you deposited the weld metal in there right, or if you damaged the material, the base material and the weld material that you just put into that weld joint. Sugaring. So sugaring is severe oxidation. This takes place on the root. If we don't have a back purge, if we don't have a shielding gas on that back side, we're going to get an oxidized weld root. And this is caused by exposure to oxygen and nitrogen. The atmosphere, those two things are not our friends. They will interact with liquid weld metal and, severely impair or damage the mechanical properties of that weld metal for us. It's going to give us a rough and nasty, grainy looking surface. And the worst part about this is we're going to lose corrosion resistance. And the whole idea behind stainless steel is, it's pretty and whatnot, but we don't want to lose corrosion resistance. Corrosion resistance is the reason we have that material there. So the root condition on that pipe on the inside, We want it to be smooth, nice. We don't want icicles or boogers or, excessive reinforcement in there. If we look inside there and it's got a sugared root, we're going to reject it. And this is where the purge quality is going to show up. Let's say you got in a hurry and you did a sloppy purge on that backside and started welding before you got the oxygen levels down below an acceptable level. It's going to show up here. It's going to show up if you took shortcuts and tried to go too fast. Or maybe your purge dams or something on the inside of this weld were damaged. Maybe there's a leak somewhere. This is where it's going to show up. So when do we stop welding? I taught a class a couple weeks ago, more sort of a class. But anyways, telling guys when to stop welding. Just stop. Just stop so we don't have to cut more stuff out. We've got problems coming in here. What do we got going on? Why you're just making more work? And they were working on practice parts, but they got the picture. One of the things, loss of shielding. If we lose our shielding, we're going to end up with problems in that weld joint. Like I said, our weld joint's going to be contaminated. The filler metal that's getting deposited as weld metal is going to, when it solidifies and oxygen and whatnot, contamination. And like it says here, we can have contamination occur on these welds. We got to have things clean. We got to have a good purge. We got to have good shielding gas flow. There's just a lot of things that need to go right for us to be successful when welding stainless steel. So bottom line, we need to inspect as we go. We need to fix bad things early. And we need to make sure that the quality is visible. We don't want to have too wide of beads, because if we've got really wide beads, we can end up with, putting too much heat into the material and damaging the mechanical and or the corrosion resistance properties of the material. Or if we've got, not evenly spaced, nasty looking, weld ripples on our weld, that's going to raise some red flags. Cracks, porosity, there's a lot of things that can go wrong with welding. So we just need to keep that in mind and make sure we fix things as we go before it gets to an escalation point where, customers or somebody else sees it, or, but we don't want to do rework anyways. But anyways, fix bad things early, inspect as you go.